Hello everyone. So today we'll be solving the problem red black cobweb, right? So this was asked in the code forces round 4 to 6 for the division 1. We can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem, right? So let's see what the question states here. One second. So yeah, here we are given a tree of n nodes, right? So we are given a tree of n nodes connected by the red or black, right? Red is represented by 0 and black is represented by 1. Just remember this. We are given a tree of n nodes connected by red or black represented by 0 or 1 threads basically, right? Each with a clamminess value, each with a clamminess value. For every pair of nodes, we consider paths. For every pair of nodes, we consider paths where the count difference between red and black edge less than or equal to 2. Where the count between the red and the black edge has to be less than or equal to 2. So this is very important, man. Just keep this in mind. And again, just let me read this one. For every pair of nodes, we consider the paths where the count difference between the red and the black edges has to be less than or equal to 2, right? For each valid path, take the product of clamminess. For each valid path, what we need to take, what we need to do here, we need to take the product of clamminess. Just remember this one. We need to take the product of clamminess, right? Just remember this one. Yeah. For each valid path, we have to take the product of the clamminess values of its edges, right? The fineness, the final jelliness of the cobweb is equivalent to the product of all these values, nothing but mod. This one is 1e7 plus, I think 1e9. So they have given 10 to the power of 9 plus 7. 1e9 plus 7, right? So if no such path exists, then we have to output 1 in that case, not the minus 1, the positive 1, right? Just remember this one. So let me read the question loud. Just listen to this carefully. We are given a tree of n nodes connected by the red or black, nothing but 0 or 1 threads, each with a clamminess value, right? For every pair of nodes, we consider the paths where the count difference between the red and the this one black edges has to be less than or equal to 2. For each valid path, we have to take the product of clamminess, right? So for each valid path, we have to take the product of clamminess values of its edges. The final jelliness of the cobweb is equivalent to the product of all these values, right? Along with this one, mod 1e9 plus 7 or 10 to the power of 9 plus 7. If no such path exists, then we have to output 1. Then we have to output 1. Just remember this one, right? Let me remove this one. Yeah. Now let's move on with the input output part. So here we have, yeah, 1 second. Yeah, 5129023512456 and this one 2450 and 255. The output that we need to get after applying the mod has to be 126 yeah 126562 and 5, right? So this is the output that we need to get, right? So let's do one thing. Same goes with the second example as well, man. This is about the input output. That's it, simple, man, right? Now, let's do one thing. As we have the idea on the question and the input output, let's discuss the approach followed by the complexities and then let's write the code. As usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question, right? Here the output that we need to get here is 12656 and we'll be going with a centroid decomposition approach, right? Centroid decomposition to solve this particular problem, right? So let's move on with the step-by-step explanation. First, what we'll do, we'll build a tree of 5 nodes as they have given in the input 5. So we'll build a tree of 5 nodes. Each edge is equivalent to the UVXC, right? Where C is nothing but it is the color, where C is the color. 0 is red and 1 is black. They have strictly mentioned in the question 0 red, black 1. Right? Then what we will do, we will traverse every possible node pair. Right? We'll traverse every possible node pair. Right? So we will check if the difference between the red and black edge is less than or equal to this criteria they have given in the question as well. Right? Now we will check every pair. Only I have listed only the valid ones so that we see that you can just go with the valid and invalid ones, but I have listed only the valid ones accordingly with the example. Right, the first input I'm speaking of. So we have considered 1, 2, 2, 3, 2, 4, and 5. The value 9, 5, 5, and 5. Right, so this is red, black, red, and black. So valid unordered node pairs and their color counts and the product I have listed here. See, 1, 3, 1, 5, 3, 4, and 4, 5. Right, where red is equivalent to 1 and black is also equivalent to 1. Right, so product for 1 comma 3 is nothing but 9 into 5, which is 45. So next one for the 1 comma 5, the product is 45 as well. For 3 comma 4 and 4 comma 5 also, product is the same actually, 25. 25 and 25 respectively, right? 45 and 45, 25 and 25 respectively. Every other pair has one color count that is equivalent to 0, and the other is greater than 0, right? Other is greater than 0, so it is invalid under the factor of 2 rule. It is invalid under the factor of 2 rule. This you will get it when we write the code, right? So this is fine. Now we'll multiply all the valid path products, right? So valid path, so we'll go with 45 twice we have and 25 twice we have. This will be 45 square into 25 square basically. So this will be 2025 into 625. We'll get the output 1265625. Right, the final output that we got here is 1265625, which is equivalent to the output that they have mentioned in the example, 1265625. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's move on with the complexities part. Just give me a second here. So what will be the time complexity here? The time complexity for the code that we'll be writing in the future would be big of n log n1. So why it is big of n log n here? Due to the centroid decomposition. As I've said, we'll be going with the centroid decomposition. Due to the centroid decomposition, where each level processes subtrees efficiently, right? So overall time complexity would lead to big of n log n. So what will be the space complexity? Space complexity would lead to big of n because we'll be going with, or we will be storing the tree, auxiliary arrays, and the recursion stack. So overall space complexity would lead to big of n. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n respectively, right? So as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. We'll be making use of the fast input and the output and the different utilities. So let me import here input output package as well as the utilities package, right? So I'll just go with, yeah. Now let's make use of the class here. Just go with the main. You can just go with any class name that's relevant to the problem, right? So first let's go with the modular value for the result I've strictly said in the question, right? I'll just go with static fina int. So let me go with mod here. Equivalent 10 to the power of 9 plus 7 they have given, right? 1 second. Let me come here. The question itself. 1 second. So 10 to the power of 9 plus 7, 1 followed by 8 zeros, right? And 7. This is fine. The next step would be, let's go with the number of nodes here. So this will be static n as well. Next step would be, let's go with the visited array for the centroid decomposition, right? So I'll just go with again static boolean. So this one, let me give VIS, nothing but the visited array. Next, let's go with the subtree sizes, red or black counts, as well as the edge weights accordingly with the question, right? So this one will be static int. Let me go with size. This is fine. Also A, B, W, right? So next, let's go with the R and Q, nothing but contribution count per edge as well as the path counts. So this one will be static. This is fine. Let me go with long for this R comma. The next part would be, let's go with the temporary frequency array for the counting. So this one will be static int t. Let's go with the graph adjacency list, and let's go with the array list that stores the current subtree nodes as well as the, let's go with the result variable. These three things, right? First, let's go with the temporary frequency. So this one will be static int again p. Now let's go with the array list as mentioned. I'll just go with static array list. This one will be int. Yep, we have to mention the array, right? So yeah, this is fine. Sorry, this one, what did I miss here? Oh, graph adjacency list I didn't consider at all, man. Yeah, let me go with this one actually. Array list. This is fine. Also, let me go with the array list that stores the current subtree nodes as well. So this one will be static array list integer oh, equals new array list. Let me complete the syntax as well as we have to go with the resulting variable, right? So I'll just go with static here. Long. Let's go with the answer here. Let me initialize this one to 1. Now let's go with the first modular exponentiation, right? So let me go with static int power. Let me go with the parameters w and v, right? So this is fine, man. Now within this method, let me assign result to 1 while p is greater than 0. Then what shall we do? If p bitwise 1 is equal to 1, result, let me assign this equal to result into x modulo mod, right? Also x equals x into x modulo mod, right? So this is fine. P, let me make use of right shift 1. And finally, what we need to do, we have to return the result variable that we have made use of, right? So let me go with the return result. So let's convert this one to int actually. Yep, it is fine. Int is enough actually. Not fine. Yeah, let me come out of this one entirely. Now we are done with the first modular this one exponentiation. Now let's do one thing. So we'll be making use of the DFS, right? Let's go with the DFS to collect the subtree data. We have to collect all the subtree data, right? So let's go with the DFS to collect the subtree data. I'll just go with static void DFS. Let me go with the parameters x, f, as well as this one a and b. This is fine. So within this method, first let's go with the total black edge count till now, and also we need the total red edge as well, right? Total black and edge, this one black and red edge count till now, right? So this one black a of x equals a. For red, it will be let me go with a b of x equals b. So this is fine. Next, we have initialized size already. Size of x initially. Let me assign this one to 1. So let me go with o dot add of x. This is fine. Next step, let me go with the for loop. This one will be int I of e of x. This is fine. So within the for loop, what shall we do? Let me go with a simple if condition here. If I of 0, if it is not equal to f, as well as, so if it is not visited, right? I can just give here visit of I of 0. I of 0. This is fine. Then within the if condition, let's recurse here dfs of I of 0. This is fine. Comma, we have to consider x as well. A plus I of, again, this time it will be I of 1. Also, we have to consider b. B plus, I'll just go with I of 1 if it is equivalent to the 0. Then 1 else 0, man. Right. So let me come out of this one entirely. I'll just go with size of x equals size of x plus of I of 0. This is fine. Yep. Let me come out of this one entirely. So now let's go with one more DFS just to find the centroid of the subtree. We are going with the centroid decomposition, right? We have to find the centroid of the subtree. Now let's go with one more DFS here. I'll just go with static void DFS. Let me name this DFS2, the second DFS basically. And let me go with X, F, as well as me go with the S, we go with RT. This is fine, man. Within this DFS2 function, first let me go with Tmax here. Let me initialize this one to, or let me assign this one to S minus size of X. So this is fine. Now let's move on with the iteration part. So this one, let me consider here I of E of X we have to consider, right? So this is fine. Let me write if condition within the for loop. So this one, if I of 0 not equal to F and not of this one, visited again the same thing, I of 0 here, what we need to do here, so let me copy the same thing here, or let me type here, let me, I'll just recurse here, dfs2 of I of 0, this is fine, X comma S comma RT. Now let's do one thing. Let's go with the tmax equals math dot max tmax comma size of this one I of 0, right? I of 0. Fine. Let me come out of this one entirely. Now, if uh, tmax, if it is less than or equal to s by 2, then let me go with the rt of 0. Let me assign this one to the x. If the centroid is found, right? Then we are doing this one. Right. So we are done with the DFS2 helper function or the helper method as well. Now we have to count the valid paths that satisfies the color difference less than or equal to 2. They have strictly mentioned in the question, black and red edge. This one has to be less than or equal to 2, right? For that one, we have to get we have to count the valid path satisfying the color difference that is less than or equal to 2. Let's go with the one more helper method here, naming get. Actually, we have to get the this one, right? Valid path. So I'll just go with static here, void get. So let me make use of array list here, the type integer. Basically, this is fine. And also, let me go with OP here. Yeah, now within the get method, first let me assign n equals 0. Also, let's move on with the iteration part. So in individual I of C, let me assign n equals. So we have to go with a maximum value, right? So I'll just go with a mat dot max of n comma. So this one will be mat dot max. So I have to go with a of I plus 1. So b of I plus 1, right? So this is fine. Arrays dot fill. So this one will be t comma 0 n into 3. This is also fine, plus 1 as well as 0, man. Yep. Now let's do one thing. Let me go with a forward counting, right? So this is black dominant. Just remember this one. We are going with a forward counting, nothing but black dominant. Let me go with a 3 for loops, man. So here this one int I of C, T of A of I into 2. This is fine. Minus B of I. This is also fine. Plus n. let me increment this one. Also, let me go with one more for loop here for int I equals n into 3. This is fine. I greater than 0 by minus. So this one will be t of I minus 1 equals t of I minus 1 plus t of I. Right. So one more for loop here, the last one. So this one will be int I of c. So here, let me consider q of I equals q of I plus. Let me go with t of, we have to go with maximum of, so n minus a of I into 2, this is fine, plus b of I, comma 0. Right, so this is fine. Finally, let's multiply this one with whole thing with the OP. Right, so after doing this, after forward counting basically, which is black dominant, what we have done here, 3 iterations. Now let's go with a backward counting instead of the forward counting. Let's go with a backward counting because here red is dominant. Initially, black was dominant. We went with a 3 for loops, right? Let me copy the same thing here and make the necessary changes. First, let me write here arrays dot fill. Let's go with t comma 0, n cube nothing but n into 3 plus 1 comma 0. Right. So now let me go with 3 for loops, right? So this one I see. So this one has to be t of b of I. Here back we are going with a backward counting, right? So this is red dominant basically. So this one will be b of I into 2. This remains same minus. So here this will be a of I. A of I plus n. We are incrementing. This remains same one. Again for I equals basically here for I equals this is not the reverse iteration. This is pure this one. What will be going with the backward counting, right? I equals 1. I less than or equal to uh, less than or equal to n into 3 here. So this one instead of I minus minus, I'll just go with I plus plus. So this one will be t of I, just t of I equals t of I plus t of I minus 1. This is fine. So then for int I of c, so we'll be going with a q of I, same thing. Q of I equals q of I minus we have to go with, right? Q of I minus. So this remains long. We have to find the maximum value itself. T of math dot max of n minus. So this one will be b of I into 2. This remains same plus a of I, right? Plus a of I. So this one has to be a of I minus 1 comma 0. Whole we are multiplying this one whole by OP, right? So this is fine. We have successfully completed the forward counting and the backward counting. Forward counting is nothing but the black dominant. Backward counting, the previous one from the line 60 to line 63, what we have written, that's backward counting, which is red dominant, right? Now let's combine the contributions from the subtree, right? So let me go with the third DFS here. Static void DFS. Sorry, let me go with here DFS 3, right? So this will be relevant here. The name I'm speaking of. We need 2 parameters. I'll just go with int x and f here. So let me go with a simple for loop here. Int basically I. So this one will be e of x. So let me go with the if condition here. If I of 0 not equal to f and not of was here, this is fine. Not visited actually. I of 0, this is fine. Then let's recurse man. So this one will be DFS 3 of I of 0. This remains same. I this one comma x. This is fine. The next step would be let's update the edge contribution here. So this one will be r of I of 2. So this is fine. R of I of 2 equals R of I of 2 plus Q of I of 0. This is fine, man. This one Q of X equals Q of X plus Q of I. Mm, I of 0 we have to go with, right? So this is fine. Finally, Q of I of 0. Let me assign this one to the 0, right? So here what we are doing, line number 70, basically, we are just updating the edge contribution here. So this is the function mainly to combine the contributions from the subtrees, right? This is fine. Let me come out of this one entirely. Now what shall we do? So let's go with this one main thing. Let's go with the centroid decomposition main recursive, right? Main recursive solve method. So let's go with the solve method and let's call the solve method within the this one. What do we call main method? Right. First, let's go with the solve method. So we are performing centroid decomposition main recursive. This one solve method here within the solve method. Just remember this one. I'll just go with static here. Sorry. Let me go with void. Let me call this one solve. I need the parameter x here. This is fine. So within the solve method, first one, I'll just go with visit of x. Let me assign this one to the Boolean value true. The next part is let me go with I need array list here, right? So this one will be integer. This is fine. C equals new array list. So this is also fine. Yep. So this one will be array list again integer. So this will be temp new array list, right? So this is also fine. The next part is let me go with c dot add of x. Yep. Now a of x equals b of x. So let me assign this one to the 0. Let me initialize this one to the 0. Now let's go with the decompose part actually. We have to decompose each child subtree, right? So let's move on with the iteration part. So here it will be I of e of x, right? So within the for loop, if suppose if not visited, right? Not visit of I of 0, then what we need to do, let me make use of the first DFS here. DFS of I of 0, I of 0, comma x. So we have to go with I of 1 as well here. Suppose if I of 1, if it is equivalent to 0, then we have to display 1 else 0, right? So this is fine. The next part would be let me call the get method here. Previously we had written the get method, right? So this one will be o comma minus 1. This is also fine. Let's go with the add operation here, or let's go with add all here, right? So let me pass o here. This is fine. Now let me go with o dot clear. We need to clear this one. So let me go with the o dot clear here. Now let me consider rt variable and assign this one to the new int of size 1. This is fine. Yup. Now let's do one thing. Let's go with the dfs2. This is fine. So this one will be I of 0, comma x, comma this one will be size of 1, size of I of 0. This is also fine, comma rt. So this one will be temp dot add of rt of 0. Right, so let me come out of this one entirely. Now let's do one thing. Let's process the total valid parts through the current centroid. So let me call get method here. Get c comma 1. Also let's recurse here. Let me go with dfs3. So we'll start with 0x comma 0. This is fine. Now let's do one thing. Let's solve recursively for the child centroid. So let's go with a iteration here. This one int I not of temp. Sorry, not for I of temp, individual I of temp, right? So I'll just go with let me call the solve function here. We are just recursing here, right? So this is fine, man. We are done with this method. Basically, we have completed the solve method. Now let's do one thing. Let's go with the main method, the last one, basically, right? So just give me a second. Delete this one, and also let me go with throws input output exception. So within the main method, first thing is we'll be going with a fast scanner here. This is related to the input output, so we don't have to. So I'll just copy paste this one later. So this is purely related to the input output. This is not related to the logic. Basically, this is fine. So fs equals, I'll consider the variable fs here. Let me go with a fast scanner. This is fine. Now let's do one thing. Let me assign n2 fs dot next int. So this is fine. Mm, let me go with the iteration part. So this one will be int I equals 1, I less than or equal to n, I plus plus. So this one will be e of I equals new array list of array list. That's it. I'll complete the syntax here. So let's go with the initialization part and let's assign to the array of size certain things, right? So I'll just go with size initially. Let me go with new int of size n plus 1, right? So this is fine. A equals new int of again n plus 1, size n plus 1. B equals new int of again size n plus 1. This is fine. Now w equals new int of size n here. This is also fine, man. Now let me go with the visited arrays. Vis equals this one new boolean of this one size n plus 1 as well. Now let me go with r equals new long of this one n, basically this is fine. Q equals new long of this one n plus 1, this is also fine. Finally t equals new int of, let me go with a value here, size basically 3 followed by 5 zeros here. One second. Yeah, 3 followed by 5 zeros here and 9. This is fine. We are done with the this one initialization part. Now let's go with let's input all the adjacent, store this one UV, weight and color, right? So let's move on with the iteration part here. So this one will be int I equals 1, I less than n. Let me increment the I. So within the for loop, let me go with j equals s dot next int. So this one k equals again fs dot next int, w equals fs dot next int. Also let me go with l equals same thing fs dot next int. Right, so this is fine. Yep. Now let me assign w of I weight to mm, double w. This is fine. Also let me go with e of j dot add of. So let me go with new int of this one. What do we call? Just give me a second here. Let me go with here k comma l comma I. Right. So k comma l comma I. So this is fine. Let me copy the same thing and make the necessary changes. So let me come here. Let me paste this one over here. So this one will be E of k dot add, this one is fine. This remains same. This will be j. Uh, L remains same actually, right? So instead of this one I, let me go with I remains same as well. So we just have to change this one to j. That's it. Uh, k from j actually. That's it. L and I remains same. So this is fine. Now let me do one thing. Let me come out of this one entirely. So I have to give semicolon here. This is fine. Now let's do one thing. We are left with only certain things here. One is we have to start the centroid decomposition from the node one, right? So we have written the main logic within the solve. So let's start the centroid decomposition from the node one. Let me pass the value one here. This is fine. Simple. Now let's go with the final product using the edge contributions, right? So let's go with the iteration part here. In I equals 1, I less than n, I plus plus. So answer equals answer into PW of W of I we have considered, comma, R of I. This is simple, R of I. We have to strictly go with the mod value they have asked us to do in the question, right? So I'll just go with the system out println here. This is fine. Let me pass answer variable. This is fine, man. Now we are done with this. We are left with only one thing, man, here. That is nothing but fast scanner. This one, this part, right? Fast scanner part, basically, right? So this one, let me copy paste this one, man. This is purely related to the input output, custom input output, right? So just give me a second here. Let me come here and let me paste this one over here. This is simple one. We have made use of the buffer data here. String tokenizer. This is purely related to the this one. What do we call? Uh, Input output. Yeah, you can just ignore this one. You can just make use of any template. It doesn't matter, man. Right. So we are done with the coding part. Now, before checking the code with the different inputs or the examples, let me do one thing. Let me copy paste the signature starter template. Just give me a second here. I'll just paste this one over here. So this is fine. Now let's do one thing. Yeah, let's check this one with the different inputs or the examples. I'll just copy this one and let me paste it over here. Right. So let me run this one. We are getting the error basically. Line number 29, static int t. So variable t is already defined in the class, right? Yeah, we have defined. So what's the problem? Oh, twice I have defined here, right? So this should be 1 second. Yeah, we have went with r comma q, then t, then we are going with oh instead of the e I have went t. So let me delete this one, man. We know we don't need this one here. Let me run this one again. Yeah, now oh we have 17 freaking errors. Okay, static after static we need space actually here. Line number 31, 31, 31, 31. Yeah, static long. So this is fine. One error is gone. Oh, three errors are gone. Okay. Now, cannot find the symbol X. Line number 36. So P bitwise and 1 if it is equivalent to 1, we are going with the result equals result into X modulo mod. X we haven't this one. What do we call? We have defined, oh, I have defined W here. This is X actually. X and yep. Now this error has to be gone. Yep. We are left with 9 errors. 4 errors are gone. Method get in the class main cannot be applied to the given types. Why? What's the problem? So I'll just come here. 104. 104. So this one within the solve, right? Within the solve we are doing. What we are doing here? DFS I've got. Okay, DFS of F0. Then get off. Oh, this one has to be O actually, not the 0. That is the reason it is screaming. I believe. Yeah. Yep. Now one error is gone. So many errors, man. So this has to be DFS3, man. 114. I have misspelled here. Yeah. Let me run this one. Yep. Now cannot find the symbol. FS. Fast scanner. I have written FS here. So where? Line number 121. So this one here itself I have made use of, man. What the heck? Just give me a second here. Fast scanner, FS equals new fast scanner. So here I have written fast scanner. Okay, I have called this one here. Yep. Why we are getting this one? This one is fine. 1 second. So this one I know why we are getting this one error because we have to go with a oh yeah, this one capital I and here as well. Next then capital I, this one capital I, this one has to be capital I as well. So let me run this one. So yeah, we are left with only two errors actually. Error array required but int found. Where is this line number 134? Yeah, this is fine. Mm, fine. So let me. So the both same errors actually. We are going with a double W here, right? 1 second. Just give me a second here. Yeah, here I have given single W man. So that is the reason it is coming. So I have been looking at this why this is giving the error cannot find symbol. Yeah, because I have given only single W here. The same thing. So this will give us the error. W we have already considered. Main long pointer cannot store to object array because main dot is null. What is this one? Why we are getting this error? Just give me a second here. So what mistake I have done here is in the line number 20, 127 actually, for the boolean I have considered the capital B. This has to be small b actually, right? So let me run this one now. Incompatible types, boolean cannot be converted to the boolean, right? Where it is visited equals new boolean. This is fine. Somewhere I have made use of the boolean. This we have to go to the initialization part, right? Let me go here. Yeah, here also I have to change this one to small b actually. Yep, now this has to work correctly. Again, main Java null point cannot store the object array because main dot e is null. 1 second. So I have forgotten one thing within the main method one. So I have called the first scanner here, and we are assigning this one to the first scanner. This one fs dot next, and this is fine. So before the for loop, I have to go with let me assign e to new this one array list actually of size n plus 1, right? So this one I have completely forgotten. Now let me run this code. Yeah, we are getting the output, correct output, right? See here 12656 basically this 125, which is correct, right? So 1265625, this is fine. Let me copy this one. We have to get the output 45 starting from the 45 and then you get 144514, right? Let's check the same here. 4514. So we are getting the correct output. So that was the mistake. I didn't add this one. So that was the mistake. And some of them were the typo, right? So this is fine. We have cleared the bugs basically. Let me copy this one entirely. Let me come here. Let me hit the submit button. Yeah. Let me paste the code over here and let me hit the submit button again. Let's wait for some time, man. Let's wait for some time. I hope this works for all the test cases, man. How many test cases are there, man? Running on test 86. Yeah, you can clearly see here the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct here. So we have went with the centroid decomposition, and we have went with the modular arithmetic as well, along with the modular exponentiation, nothing but the modular arithmetic itself, then along with the DFS to solve this particular problem. Centroid decomposition, modular arithmetic, along with the this one, mainly modular exponentiation with the DFS. Three DFS helper methods we have made use of, mainly DFS, right? So to solve this particular problem. Now, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.